Hello everyone. Now we are going to discuss about golden section search method. We'll implement this algorithm using CPP. The index page goes like golden section search algorithm, problem statement, real-time application, implementation, and finally the conclusion. We'll start our discussion by understanding the core idea of golden section search algorithm. Generally, golden section search algorithm is one dimension search method. You can see golden section search method is a technique which helps in figuring out the maximum or minimum of a strictly unimodal function. First of all, the property that we assume of the objective function f is that it is unimodal function, which means that the function has only one local minima. Let's come to second point. Golden section method is an iterative process in certain domain of function. This method includes successively narrowing the range of values. So this method is based on evaluating the objective function at different points in the interval, let say a naught to b naught. We choose these points in such a way that an approximation to the minimizer of f may be achieved in as few evolution as possible. As you see the fourth point, the technique derives its name from the fact that the algorithm maintains the function values for triples of points whose distance form a golden ratio. Final point, the golden section search method is performed by initially choosing two interval points of the interval. So that the distance of the rightmost internal point to the distance of the rightmost endpoint to the leftmost internal point. So thus dividing a range in the ratio of p to 1 minus p has the effect that the ratio of the shorter segment to the longer equals the ratio of longer to the sum of the two. This rule was referred by an ancient Greek geometrist as the golden section. Using this golden section rule means that every stage of the uncertainty range reduction, the objective function f need to be evaluated at only new point. So thus the uncertain range is reduced by the ratio of 1 minus p, that is approximately 0.61803. This happens at every stage of our evaluation. So if there are n steps of reduction using the golden section method, this reduces the range by factor of n, that is 1 minus p whole power of n approximately 0.61803 to the power of n. After calculation of f function value at 2 points, then by comparing them we can obtain that if the required is minima, then we have discard the values that are beyond maximum obtained. And if the required is maxima, there's a maximum value, then we have to discard the values that are before minima obtained from the two intermediate points, let's say x1 and x2. Graphical representation is given like this, that the two interval points xl x lower and xu x upper, the two intermediate points is given by x1 and x2. So we will compare these 2 points, then we will decide that in the which direction we have to go according to the question given. If they ask minima, if they ask maxima, we apply these two. conditions given here. Now the problem statement is, so given a function value f of x cube minus 6x square plus 11x minus 6, interval is given, that is a comma b is equal to 0 comma 4, and the tolerance level is set to 0.0001. So we are going to calculate the values of x1 and x2, the two intermediate points. Goes like x1 is equal to a plus 0.382 into b minus a, x2 is a plus 0.618 into b minus a. Like golden section rule, applying them, we can evaluate the x1 and x2. So if x1 is less than x2, then the minimum value is in the interval of a to x2, that is 0 to x2. So set b is equal to x2 and calculate new values of x1 and x2 using the golden section search form. But if the f of x1 is greater than f of x2, then the minimum value is in the interval of x1 comma b, is x1 comma 4. So set a is equal to x1 and calculate the new values of x1 and x2 using the golden section search form. So we are going to repeat the steps until the difference between b and a is less than or equal to the tolerance level. If the tolerance level is set to 0.0001. So using this method, so we can find the minimum value of the function, the f of x, for x cube minus 6x square plus 11x minus 6 in the interval of 0 comma 4 given by the 1.857, which occurs x is equal to 2.5. So the iterative box is given like this. The a comma b values is simply the interval. So after the first step, the interval is minimized. The second iteration is furthermore is given like this. For that, x1 and x2 values and the evaluation values. So real-time application is mainly used to track maximum power point tracking control and contemplation for photovoltaic systems to escalate their efficiency of power generation. It is mandated to locate the maximum power point under all possible illumination conditions. Maximum power point tracking control is expected to obtain the MPP irrespective of the device and climatic changes. Assume a line segment as shown figure 11.1. It gives from 0 to V0C. Length from B to X1 is given by R. Length of X2 is given by 1. Spectrum operation from 0 to open circuit is given in the graph. Maximum or the minimum value obtained by using the goal and section search algorithm is used as the feedback voltage to the single input and multiple output DC to DC circuit. So here where the application of golden section search lies in giving the feedback voltage. So algorithm were tested at various irradiation conditions while it was recorded, variation of duty cycle for different irradiation conditions. Implementation of the golden section search method in the CPP is in here. Initializing the program, defining the function, objective function. X square minus 4x plus 3 is the objective function we have taken. The floating points is double. First initializing the golden ratio 3 minus root 5 by 2. Initializing the x1, x2, and after we are going to evaluate the f of x1 that we are going to store in the f of 1 and f of 2. So the same condition, the two conditions that we have discussed, like minimizing the interval according to the values obtained from f of x1 and f of x2. So you can see the comparison and then the process. And we are going to initialize the new interval, the new minimized interval. And I also set the tolerance level. We have initialized the given interval at the beginning of the interval, the given function. For the output, we have given the printf command. With this, we can implement the required golden section method in CPP. So coming to the conclusion part, method is effectively used in unimodal optimization. It results in least number of searches or trials to locate the optimal value. Narrows search interval by less than half each time. So they used Boolean section search based maximum power point tracking strategy for a dual output DC to DC converter generally used in the feedback form. So the disadvantage of this method is it's only suit for the unimodal functions, and also it is only one dimension. So this is the overview of a golden section method. Thank you.